All right, boys and girls, this is Math Message 5-9, the main math lesson of the day. And in today's math lesson, we're going to use square facts to help us solve near square problems. And you'll see what I mean by that here in just a couple of minutes. Now, I want you to start out this lesson. You're going to need your workbook here in a little bit, but I want you to start off the lesson with just a piece of paper or a whiteboard and marker, and I'm going to give you a couple of things to do. So go ahead and gather your things and get ready. Okay, the first thing I want you to do is make a list of square facts. Now remember what a square fact is. A multiplication square is a lot like our doubles facts that we had in addition. So like 2 plus 2, 3 plus 3, 4 plus 4. But with multiplication square facts, it's with, of course, multiplication. Now, we don't call these doubles facts, we call them multiplication squares, and let me remind you why. So 2 times 2 is an example of a multiplication square, because if I did a 2 by 2 array, of course it's going to make a perfect square. 3 times 3 is another example of a multiplication square. And again, if I did a 3 by 3 array, it would make a perfect square. So these are called our square facts. Now, just like with your doubles facts and addition, we expect you to have these facts memorized for some fact fluency. And we've been working on these since Unit 3. So they should be very, very familiar to you. So go ahead and I want you to pause the video and I want you to make a list of all of your square facts where you have the same factors. And I want you to make all your square facts starting with 2 times 2 all the way down to 10 times 10. Pause the video, please. Okay, so here's the list of multiplication squares that you should have on your paper. And these facts should be something that you knew the answer to them right away. Now, if you know the answer to these facts, you should be able to use these as helper facts to help you solve problems that are near squares. Now, let's look at when we were doing this with addition. Let's say that you knew what 6 plus 6 was. You know that 6 plus 6 is 12. Then your teacher had you use that fact to help you do 6 plus 7. And you know that the answer is just one more. Or if you knew what 8 plus 8 was, then you should know what 8 plus 9 is because, again, it's just one more. Well, that's kind of what we're doing with our square facts, looking at our near square facts, except with multiplication, you're not just adding on one more, you're adding on one more whole group. And we did this clear back, I want to say it was also in Unit 3 when we were doing helper fact strategies and we were doing add a group and subtract a group strategies. So now I want you to now make a list. If you know what 2 times 2 is, I want you to make a list of another problem that's near that you could solve. So for example, if I know what 2 times 2 is, I can use it to help me solve 2 times 3. Okay? If I know what 3 times 3 is, I can use it to help me solve 3 times 4. If I know what 4 times 4 is, I can use it to help me solve 4 times 5. 5 times 5, I can use it to help me solve 5 times 6. 6 times 6, I can use that to help me solve 6 times 7. 7 times 7 will help me solve 7 times 8. 8 times 8 will help me solve 8 times 9. 9 times 9 will help me solve 9 times 10, which really you shouldn't need anything to help you with that, right? And 10 times 10 can help me solve 10 times 11. Now, boys and girls, there are some of these that you don't need to use the helper fact strategy or the near square strategy. Like 2 times 3, you should just be able to do that one. 4 times 5, you should be able to do easy. 5 times 6, you should be able to do easy. 9 times 10 and 10 times 11. We have other strategies that we've learned this year that's going to be much quicker than even using this near square as a helper fact. But this is what I mean by near squares. These problems are close to our square facts. They're just one off. Now we have to treat them differently with multiplication, and let's look at a problem. So let's say that Callie knows what 7 times 7 is. She knows that it's 49. How could she use 7 times 7 as a helper fact to figure out 8 times 7. Here's what I want you to do for this problem. I want you to draw a 7 by 7 array, and you know that that's going to be 49. And then I want you to turn that array into an 8 times 7. Go ahead and pause the video and do that. Okay, so here's my 7 by 7 array. Now, if I already know that 7 times 7 is 49, if I want to turn this into 8 times 7, instead of having 7 rows of 7, now I'm going to have 8 rows of 7. So what did I need to do to get my answer? I just needed to add on 8 more, okay, which would give me what? Or I'm sorry, I didn't need to add on 8 more. Let me take that back. Hold on a second. My brain is skipping to a different problem. So I had 7 rows of 7. Now I have 8 rows of 7. So how many did I add on? I only added on 7 more because I was just adding on another row of 7. I apologize. I wasn't really focusing. 49 plus 7. And when I do 49 plus 7, I get 56. Now, we did this a long time ago when we were working on helper fact strategies and when we were doing add a group and subtract a group. And I was making you draw out these arrays. I want us to get to the point to where we don't have to draw out these big old arrays anymore. I want you to be able to just simply look at it like this. So if I know that 7 times 7 is 49, if I am using that to help me solve 7 times 8, I know that 7 times 8 is going to be bigger, right? It's going to be bigger than 7 times 7. So I know I need to add something on. Now, what do I need to add on? Well, I'm going to look to see what factor is the same in both problems. I know that I'm adding on another row of 7 or another group of 7. So 49 plus 7 is 56. Okay, we're going to practice this with a couple of problems. Let me give you another one to do. Let's say that I want you to solve 8 times 9. What would be a good helper fact to help you solve 8 times 9? Pause the video, give yourself time to think. All right, I would choose 8 times 8. And guys, I always choose to double the smaller factor. And the reason I choose to do that is because then I'll be adding on a group instead of subtracting a group. And you know I don't like subtraction, so I try to avoid it at all costs. So if I choose the smaller factor to double, then I'll have to add on a group. So I'm going to do 8 times 8, and I know that 8 times 8 is 64. Now I have to solve 8 times 9 using this. I know that 8 times 9 is going to be bigger, right? Because 9 is bigger than 8, so I'm going to have to add on. Now, what will I need to add on? There's an 8 in both of these problems, so I know I'm adding on a group of 8. So 64 plus 8 is 72. All right, let's try a couple in our workbook. Go ahead and turn in your workbook to lesson 5-9. And I don't have my workbook in front of me, so I don't know what page number that is. But if you just go look for lesson 5-9, look for the page that says Exploring Near Squares. So go ahead and pause your video and get that ready. All right, let's do number 1 together. Here's my near square fact, 3 times 4. I know it's near a square because the numbers are just 1 away from each other. So I'm going to pick a square helper fact. Now, again, I like to choose the smaller factor. So I'm going to make 3 times 3 my helper fact. And I easily know that 3 times 3 is what? 3 times 3 is 9. Now, 3 times 4 is going to be bigger than 3 times 3. So I need to add on to get my answer. What do I need to add on? Which number is in both problems? 3, right? There's a 3 in this problem and there's a 3 in this problem. So that's what I'm adding on. 9 plus 3 equals 12. So my answer is 12. Now this says how I solved it. As long as you're showing me all of that work, I'm perfectly happy with that. If I do ask you to put that in words, all you would need to say is, I added a group of 3. Okay? All right, let's look at number 2. I want you to find a multiplication square to help you solve 7 times 6. Go ahead and pause the video. Give yourself time to work this out, just like we did the problem above. And then hit the play button, and I'll go through it with you. Okay, now once again, I would have chosen the smaller factor to double. So 6 times 6 is 36. Okay. Now, to get 7 times 6, I know that I need to add because 7 is bigger than 6. So I knew I need to add on something. What do I need to add on? Well, which number is in both problems? I have a 6 in this problem and a 6 in this problem. So I know I'm adding on a group of 6. So 36 plus 6 is 42. All right, let's go ahead and do 9 times 8. Actually, you know what? I'm going to show you something because maybe you chose a different square fact for 7 times 6. So let me do that real quick. Let's say you chose to do 7 times 7, which would be totally fine. You could do that. But let me show you why I don't like to choose the bigger factor. 7 times 7 is 49. Now, in order to get 7 times 6, this is going to be smaller, right? 6 is smaller than 7, so I'm going to have to subtract, which isn't my favorite thing to do. What am I going to have to subtract? Well, there's a 7 in this problem and a 7 in this problem, so I'll need to subtract 7. 49 minus 7 is 42. So, of course, I'm still going to get the same number. It's just I'm going to have to subtract a group instead of add a group. All right, let's go ahead and do 9 times 8. Pause the video, solve this problem, and then restart, and we'll check it together. All right, again, I would have chosen the smaller factor to double. So 8 times 8 is 64. And now I know that 9 times 8 is going to be bigger because 9 is bigger than 8. So I have to add a group. And what am I going to add on? What number is in both problems? There's an 8 in this problem and an 8 in this problem. So 64 plus 8 equals 72. And again, if you would have chosen to use the other factor, 9 times 8, let's say you would have done 9 times 9 is 81. That's okay. But now you know that this is going to be smaller because 8 is smaller than 9. So you're going to subtract a group. This time you'll subtract a group of 9. 81 minus 9 still would give you 72. All right. So now for the last one, it just says do your own. So you get to pick whatever near square fact you want to do. Maybe challenge yourself. Maybe if you know that, let's see here, you know that, well, let's just do 10 times 11, okay? Now, you know what 10 times 11 is going to be, but maybe you could then use your square helper fact strategy to solve it rather than putting the 0 on the end. All right, the next thing I want you to do for this lesson is I want you to find the page. Hold on a second. Find the page that looks like this in your workbook. It's got all the different multiplication facts, clear from 0 times 0, clear up to 10 times 10. I want you to go through and see how many of these you can answer very quickly. Now, you should be able to answer all of your square facts, your 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. You should be able to answer all of those facts very quickly and easily. Because you can answer those facts, you should be able to answer the facts on both sides of those. Okay, so go down through and answer all of those. You should be able to answer anything times 5, anything times 2 and anything times 10, you should be able to answer right away. So go through here and see how many facts you can answer very, very quickly. We should be really building up that fact fluency by this time in the year. And then once you do that, boys and girls, there is one more thing I would like for you to do for this lesson. If you turn to page, and I think it's page 182, whoops, page 182, again, make sure it says 5-9 and it says subtraction practice. And of course, subtraction is something that we've already worked on this year. So this is just a practice page. You know, we always have to practice so that we don't forget how to do something. It's 3-digit subtraction. Now they say to use the expand and trade strategy to solve it, but by this time in the year we've learned several different subtraction strategies. You can choose the strategy that works best for you. Okay, so if expand and trade is a strategy you like, use it. If this isn't your favorite strategy, then don't use it. Use whatever strategy works for you. So go ahead and pause the video, do that multiplication page, then do this page, and then you can start the video, and I'll check this work over with you to make sure you have all the correct answers. All right, hopefully you've given yourself a chance to do all these. Boys and girls, if you have not, please make sure you do pause these videos and that you do the work. Don't just watch me do it. Don't just sit there like you're watching a video or you're watching a movie. I want you to really be working on these problems and then use the video to help check yourself. All right, so let's first do our estimate. 580, I'm going to say, you know what, that's already an easy number, so I'm just going to keep it 580. Minus 446, let's change that to 450. And we'll go ahead and do our subtraction. We'll do our 500 minus 400, which would give me 100, right? And then 80 minus 50. 80 minus 50 would be 30. So my answer should be close to about 130. All right, let's go ahead and do the problem. Now, you can stack that problem. I'm going to go ahead and just use the old-fashioned algorithm. We have worked on that this year, and some of you are getting very, very good at that strategy. You may have used a different strategy, but I just want you to mainly check your answer. Okay, so when I'm doing the old-fashioned algorithm, I'm going through, I'm checking each place value and making sure there's more on top. So I see in ones place there's not more on top, so I'll borrow from my tens place, make that a 7, bring over 110 and put it in front of my ones. So I have 10 minus 6, that's more on top. In my tens place, I have more on top. And in my hundreds place, I have more on top. Now I can subtract. 10 minus 6 is 4, 7 minus 4 is 3, 5 minus 4 is 1. So my answer is 134, which is really close to my estimate. All right, looking at number 3, 704 is really close to 700. 285, you know what, I'm going to go ahead and round this to the nearest hundreds too, because that's pretty close to 300. 700 minus 300 would give me 400. Let me go ahead and stack my problem up. Always make sure your ones and your tens and your hundreds are all lined up. And now I'm going to make sure there's more on top. All right, in my ones place, there's not more on top. I need to go borrow. But when I go borrow from the tens place, there are no tens to borrow. And I can only borrow from the tens. So I'm going to hang tight for a second. My tens place can go over and borrow from my hundreds place. So when I borrow 100, I put that 100 in the tens place there. Now I can borrow from the tens. So now there are 9 tens, bring that 110 over in my ones place, and now I have 14 ones. So when I go through and I check each place value, I have more on top. I can now subtract. 14 minus 5 is 9, 9 minus 8 is 1, and 6 minus 2 is 2, or I'm sorry, 6 minus 2, sorry about that, is 4. So my answer is 419, and when I check that against my estimate, I'm pretty close. All right, using 510 minus 355. I'm going to go ahead and round this to 500. It's close enough. and then minus 300, let's do it 360. Now you may have used different numbers to estimate. Remember, when you're estimating, you can round to the nearest tens or the nearest hundreds. So you may have used different numbers, and that's okay. When you're rounding to the nearest tens, you'll get closer to the real answer. When you round to the nearest hundreds, it'll be easier. All right, so let's do my 500 minus 300, which gives me 200. Now I don't have anything here, so I'm just going to have to go ahead and subtract the 60 from the 200. So 200 minus 60, my answer should be close to 140. All right, I'll go ahead and stack my problem up. 510 minus 355. I'm going to go through each place value, make sure there's more on top. In my ones place, there's not more on top, so I'll go and borrow from the tens. When I borrow that 10, I'll bring it over to the ones place. All right, now there's not more on top in the tens place, so I'll go borrow from the hundreds, make that a 400, bring that 100 over and stick it in the tens place because that's now 10 tens. Okay, now I'm ready to subtract. 10 minus 5 is 5, 10 minus 5 is 5, and 4 minus 3 is 1. So my answer is 155, and that, whoops, pointed the wrong thing. That is pretty close to my estimate of 140. All right, boys and girls, that is it for lesson 5-9. In this lesson, we were learning how to use square facts to help us solve near square facts, and then we practiced again with our 3-digit subtraction.